Hello my dear students, once again welcome to your online class. Today we will learn chapter 2, Force and Pressure of your physics textbook. So starting with this chapter, you already know that the force is the cause that can change the body's state. Now coming to the term state, we know that in physics there are two states. The body can either be in rest or it can be in a motion. So when is the body said to be at rest? The body is said to be at rest when it does not change its position with respect to its surrounding. For example, a book laying on a table, or even the tube light in a houses, or a tree near the road, all of them they are at rest. Now coming to the motion, a body is said to be in a motion if it continuously changes its position with respect to its surrounding. For example, a train, or you can even see so many other examples which are in a continuous motion, like whenever you stand in a market and then you see so many of the vehicles moving on the road, all of them they are said to be in motion. So now since you have understood the rest and a motion, so this rest and motion are said to be the relative terms. Now the relative terms, in the sense it means that it depends upon the person who is viewing at the things. For example, a person sitting in a bus and looking at the roof of a bus, what happens? He sees the roof of the bus is in rest, but whereas the person standing outside the bus, and when he looks at the roof of the bus, he will see the roof of the bus moving along with the bus. So that is how the rest and motion, it depends upon the person who is viewing at it. The same object, for you it may be at rest, and for me it may be in a motion. So that's why they are known as relative terms. Now since this chapter is about motion, so we are going to learn about the various types of motion. So first type of motion we have is rectilinear motion. This rectilinear motion can also be termed as a linear motion, because linear means in a straight line. So whenever an object moves in a straight line, it is said to be a rectilinear motion. For example, a train moving in a straight track is an example of rectilinear motion. Now coming to the circular motion, so the name itself suggests if a body moves in a circular path. For example, in a racing track, the car moves in the same circular path again and again. Such kind of motions are said to be a circular motion. Then comes the oscillatory motion. So the oscillatory motions are those motions in which the object moves to and fro rapidly. So such motions are said to be the oscillatory motion. For example, a wall clock. Some of the wall clocks they have a pendulum which swings. So such kind of motions are known as a oscillatory motion. And the fourth kind of motion we have is a periodic and non-periodic motion. So the periodic motions are those which occurs after a regular interval of time. Non-periodic motions are those which does not occur at a regular interval of time. For example, non-periodic motion is an accident. You never know when the accident occurs. If you collide with something today evening, it doesn't mean that you will collide tomorrow and day after tomorrow as well. And periodic motions means which repeats regularly after a certain interval of time. For example, when you were coming to school, just like your first period, like your class teacher taking the attendance, every day he takes your attendance. So such motions or such things are said to be the periodic. For example, another example of periodic motion is a rising of a sun. So the rising of the sun rises every morning. Such motions are said to be the periodic and non-periodic motion. So in the next part of your book, we have a simple pendulum. Now what is a simple pendulum? A simple pendulum is nothing so complicated. It's just a heavy object suspended by a thread, and this thread, it must be a elastic thread. Now elastic in the sense it means that it should not get elongate when we suspend a load. So a heavy object suspended by a thread is known as a simple pendulum. So coming to the simple pendulum, when it is at rest, like the position A, it's said to be a mean position. So the resting position is known as the mean position. Now when you apply a force to this bob, it goes to one of the extreme point B. This is said to be the extreme point or extreme position, PO position, and so does it comes to the other side at C, and this is also known as the extreme position. So there are two extreme positions when a simple pendulum is in motion. Now coming to the terms related to the simple pendulum, you see that there are 5 terms related to the simple pendulum. The first one being the oscillation. So what is oscillation? So when you slightly displace the bob from its mean position, it comes to B and then it comes back to A and then goes to C and then again comes back to A, and this goes on and on. So this to and fro motion is said to be the oscillation. Now coming to the second term, amplitude. Now what does the amplitude means? The amplitude means the maximum displacement of the particle from the mean position is said to be the amplitude. Here initially the bob was at position A, now when you apply a force it goes to the position B. So the distance between A and B is said to be the amplitude, usually given by A. Now coming to the time period, which is generally given by T. So what is time period? The time period is the time taken by the bob to complete one oscillation, like the time taken by this bob to travel from A to B, B to A to C and C to A is said to be the time period. Now coming to the frequency, it is generally given by F. What is the frequency? The frequency is the total number of oscillations that the bob makes in 1 second. Like if in 1 second, if the bob moves 2 times, then the frequency is 2. If the bob moves 5 times, then the frequency is said to be 5. Now coming to the last term, the length of the pendulum. It's nothing but very simple. The length of the pendulum is the length of the thread that holds the bob. So here, which is generally given by N. So clear? So now coming to the factors that affects the time period of the pendulum. Generally, all of these factors, the first 4 factors, they does not affect the time period of the pendulum.